Alright guys, welcome back. So we're going to start chapter 6. And in chapter 6 we're going to be working on finding statistics. Okay, so if we've taken a sample and we've collected our data, what do we do with it? We've looked previously at how to make a frequency table and also a histogram. Okay, so that's one way we can organize that data and begin to let that data tell us a story about what's happening. Okay, and so in section 6a here we're going to look at primarily we're going to focus on finding a measure of what's called central tendency. Okay, so if we could, let's say we have a set of quantitative data. If we could find one number that best summarizes, or arguably best summarizes, that whole data set, what would it be? Okay. All right. So we've talked a little bit, or well, maybe we haven't, about distributions of a variable. So the variable is just whatever we're interested in measuring. Okay. So it could, for example, it could be time spent on social media per week by, I don't know, children age 13 to 18 years old. Okay, and so the data would consist of measurements in hours or minutes, however, whatever unit is used. And so let's say we collect some data. What do we do with that data? Or how, in other words, how is the data spread out? Okay. So a distribution is basically what if we were to make a histogram, what would it look like? How is that data spread out? Is it clustered? Is most of the data within, within these first two bins, or is the data uniformly spread out, etc.? Okay. And what we have right here is an example. I know we made one, but here's another example. This is just the histogram from the data that pertain to the ages of the Academy Award-winning female actresses, okay, or actors. So how old were they when they won their first Oscar or Academy Award? And if you guys remember, we talked about this. Most are going to be in their 20s, their 30s, and then their 40s, and then we see a real decline after that. Sort of a small resurgence right here in the 60s. But this right here is a distribution, and so by looking at this visually, we can tell that most of the data is over here on the left-hand side. Or in other words, most of the data is in the age group, in the ages from 20 to 40. Okay, that's where the majority of the data is clustered. All right, so now we want to talk about, so of all that data, what might be the average age for which an actress wins her first Academy Award. Okay, so that's what we're going to look at today. Okay, so what is average? It says 3 common ways of characterizing the center of a data distribution. All of which sometimes are called the average. So the first thing we're going to talk about is something called the mean. So the mean is just a word or term that's used in statistics to denote the average. Okay, and some of you may remember actually how to find the average or the mean of a data set. It's typically denoted by this Greek letter. This is pronounced mu, mu, okay? Okay. And this is the Greek letter right here. In statistics, we use a lot of Greek letters, okay? So mu actually represents the average of the population. But recall, lots of times we take a sample and use the sample to approximate the population. So mu would be the population parameter, the true average of the population. But because we rely on samples, we we are going to be using the statistic x bar, okay? So it's just an x with a bar over it. So mu pertains to a population. It's the average of a population, or it's a parameter. And then x bar refers to the average of a sample. Okay? And so we'll basically be working with x bar because we're going to be working with sample data. Okay? But if you were given data and it was supposedly from a population, then the mean would be denoted as mu. Okay? So just remember that difference there. And so how do we find the mean? Well, you sum up all the values in your data set, okay, and then you divide by the total number of values. Okay, so if I sampled 10 Academy Award-winning actresses, I would add up all their ages, and then I would divide by 10 because I had 10 data values. All right, now geometrically, if you have a histogram, what the mean denotes is the center point, or in other words, the point for which all this data in this histogram would actually balance. Okay, so you can think about the mean as sort of like the fulcrum. It's essentially where you have just as much weight on one side as you have on the other side. Okay, up here, you know, it might be, I don't know, maybe around this point right here. That might be the balancing point, whatever age that is, maybe 35 or 36. Okay, where you have just as many data values or data weights, the weights of those data values on the left-hand side as you have on the right-hand side. Okay. All right. So the mean is one way for us to determine the central tendency, or kind of the center of the data distribution. Another way, and lots of times this next measure is actually more accurate, it's called the median. Okay, so the word median, think about the median on a road. The median divides the road into two lanes, doesn't it? So the median of a data set is going to be the middle value of the data that's sorted. So to find the median, we have to put the data in order from least to greatest. Or I suppose you could put it from greatest, list it from greatest to least. But it's more commonly sorted in ascending order from least to greatest. So you put the data in order and you see if there's a middle value. Okay? Now if there's an odd number of data values, there will be one number in the middle. But if there's an even number of data values, there's actually going to be two middle values in the middle. And what you do is you actually take the average of those two middle values to find the median. Okay? So the median takes less into account the actual values of the data. It just finds the value that's in the middle, of the entire data set. The mean actually takes into account the actual data values, okay? And we'll see why this can produce different results here in a minute. We'll see how lots of times the median will give us a better estimation of where the middle of the data set is. And the mean can often be skewed. And then the last one that we'll look at is something called the mode. So the mode of the data set is simply just going to be the most common value in a distribution. Okay? So in other words, is there a value that's repeated more than once? Now you can have more than one mode. There can be 2 modes or 3 modes in a data set. So for example, what if there are 2 values that occur 5 times in a data set and the rest of the values only occur once? Well, there would be 2 modes corresponding to those 2 individual values that are repeated 5 times. Okay. All right, so these are the 3 different measures of central tendency that we're going to be looking at using to describe the data set. All right, so let's look at example 1 here. So we've got some data. The data comes from, it's a sample of from 8 grocery stores of this particular energy bar, okay? And we're looking at the prices of this particular energy bar taken from 8 grocery stores, okay? And so what we want to do is we want to find the mean, we want to find the median, and the mode for this data set, okay? So we'll start with the mean. Now, I would assume that this is a sample of 8 grocery stores, okay? So I would say we're going to let X bar designate the mean here, okay? And so what it's going to be is we are going to find the sum of all the data values, and then we're going to divide that by 8, because there's 8 data values here, because we sampled from 8 different grocery stores. I want to also show you another Greek symbol, or Greek letter. So there's a Greek letter that we use to designate a sum of numbers, or sum of data. And it's this symbol right here, okay, sigma. Okay, so sometimes you'll see this, so sometimes you could see it written like this. That letter sigma and then the word data. So what this means is the sum of the data, okay? So the sum of all that data divided by 8. And of course, you know, you could just plug this into your calculator. I'm going to show you 2 ways to actually do this. So the first thing is a bit laborious in that I have to literally input each individual data value and I have to keep pressing plus and plus. Okay. I think I've got 8 data values in there. I'm going to hit enter. And so that's the sum of the data, $11.28. Okay. And then I'll divide this by 8, and I'll probably round to the nearest cent. And so divided by 8, and get $1.41. Okay, so we can say that the mean, or the average cost of this particular energy bar is $1.41. Okay, now this is a statistic, okay, because it comes from the sample data. We would use this statistic though to give us an approximation or an estimation about the true average. Okay, the true average would be the average from all grocery stores. Okay, the cost of the energy bar from all grocery stores. But this gives us an idea. This is an estimate. Okay. All right, now what about the median? Well, the median is going to be the center value, or the average of the 2 middle values. Okay. So remember, you've got to order your data first whenever you're trying to find the median. A lot of students forget this and they get the wrong median. Fortunately for us guys, this data set has already been ordered. It's already been put in ascending order from least to greatest. And so if I'm doing this manually, what I would do is maybe just start marking off these data values from each end, one by one, until I arrive at 1 value in the middle or 2 values in the middle. In this case, it's going to be 2 values, okay? And so what I do now is I take the average of those 2 values. So $1.35 plus $1.39. I'll divide that by 2, and this one I can kind of do in my head. This will be $1.37. In other words, guys, I can see that the halfway point between $1.35 and $1.39 is $1.37. So the median price is $1.37. So these are both measures of central tendency, or the center of this data distribution here. But you can see they're not quite the same, are they? And then finally, we're going to find the mode. So the mode is simply going to be the data value or values that occurs the most. When I'm looking here, and it looks like all these values occur once except for $1.29, which actually occurs twice. So the mode is $1.29. Okay. So we've used these three different statistics, and they've given us three different values as to what the center of this data is. Okay. All right, and we already addressed this question here. What if there were an even number of pieces of data? How would you determine the median? Well, you take the two middle values and you average them. Okay. Now, before we go on, what I want to show you is how you can use your calculator to perform some of these define some of these statistics for you. And this is why I recommend that you either have this calculator or you have this app or some similar app. Okay? Because there's a statistics program in this calculator, and it's very useful, guys. What you have to do is you actually have to input this data. Okay? And you have to input it in a list. And then whenever you want to find the mean or the median, you have to tell the calculator to find those statistics using that list of data. Okay? So where do we go to actually input the data? Well, you come over here to the stat key, you press enter, and edit is automatically highlighting. Okay, so you go ahead and hit enter. And what that does is that takes you to one of these lists. Okay. Now yours is probably going to start off with list 1, and then go to list 2 and list 3, etc. It doesn't matter what list you use, but whenever you tell the calculator to perform the operations with that set of data, you have to refer to that list. Okay? And in most calculators, list 1 is in there by default. So if I were you, I would put your data under list 1. But for some reason, okay, so here's my list 1. Okay, so you can see that I've actually already got some data in here. So what I'm going to do is, I'm going to clear that data. Okay, hit enter. And now I'm going to go in here and list each of these data values and type them in. Now this part you have to be careful with, because if you mistype one data value, it'll mess everything up. Okay, so each time you input a data value, you hit enter. Okay, so just do this for your entire data set. Alright, so I've got the 8 data values in there. Now, where do I go to tell the calculator to actually find the mean of this set of data? Well, you're going to go over here to stat again, the stat key again, but you're not going to go to edit. You're going to scroll to the right where it says calculate. Okay? And this one variable statistics is highlighted. That's what you're going to use, because we're finding statistics for one variable. The variable in this case is just the price data, just the price of this candy bar, or this energy bar at these different grocery stores. So I'm going to hit enter, and this is where it says list. This is where you have to make sure that you have the proper list. So since I put my data under list 1, then I need to put list 1 in there. And the easiest way to do this, guys, is probably coming down here above these numeral keys. You see L1, L2, L3, etc. So I want to put in there list 1. So I'm going to hit the second key and then number 1, and that puts in there list 1. And I'm just going to scroll down to calculate and hit enter, and it'll calculate the statistics. So look here, it's given us X bar, which again, remember, represents the sample mean, and it says it's $1.41, and that's actually what we obtained right there. Now don't worry so much about this stuff right here for now. We'll talk about that later on. But notice it gives us n equals 8. N represents the size of the sample. So the sample consisted of eight data values, so it tells us that there were 8 data values. And if you scroll down, it'll start giving us some other statistics. So it'll give us the minimum value, it'll give us the maximum value, and then we'll talk about what this Q1 and Q3 mean later on, but it also gives us the median right here in the middle, and it's $1.37, and you can see that's what we came up with as well. Okay. The one thing it will not give us, guys, is the mode. Okay, so that you have to find manually. But anyway, do use this calculator if you can. Actually, you are definitely going to need to, because when we go to the next section, we're going to be calculating something called the standard deviation, and it's very difficult to do by hand. It involves a lot of calculations. Okay. All right, well, let's keep going. It's probably going to take me maybe 2 or 3 for this section. Okay, so let's talk about, so I briefly mentioned that the mean and the median may not be the same. The median is not affected by the actual values in your data set. It just finds the value that's in the middle, and that's it. But the mean is affected by the actual values. Okay? So let's first talk about what an outlier is. So an outlier in a data set is a value that's either much higher or lower than almost all the other values in the data set. And because of that, it can change the mean of the data set significantly. But it's not going to affect the median or the mode. Okay? So for example, these values here, I don't really see any outliers, but what if at one grocery store this energy bar sold for $4.50, and that was in this data set? Then that would be an example of an outlier. That one value, because it's so high, it will affect the mean. It'll pull that mean upward, and it'll make this average look a lot higher than it actually is. Okay. Or another outlier maybe on the lower, well, I don't know if you would see one on the lower side, because $1.09 is already pretty low, but you know, this data was taken from a grocery store, so as you guys know, things are much more expensive at gas stations. So if you were to have selected the price of this energy bar at a gas station, it could be like $4. But anyway, so to illustrate this to you, let's look at this example 2. Okay, it says a track coach wants to determine an appropriate heart rate for her athletes during their workouts. And so she reads the following heart rates off of a heart monitor for 5 of her best runners. So what she's done is she's taken a sample of 5 of her best runners, and she's recorded their heart rates. And this is what they are: 130, 135, 140, 145, and then 325. My guess would be that the 325 is probably an outlier. Okay? And it is, guys. In fact, it's probably an error. You cannot even have a heart rate that's that high. It's physically impossible for your heart to beat that fast. Okay, so probably that was just a recording error or an error in the heart monitor. Okay? But what we're going to do is we're going to calculate the mean and the median. Okay. And so I'm going to go back and use my calculator to do it, to illustrate this to you again. So I'm going to come back here to the stat key. I'm going to go to Edit, and I'm going to scroll up here to list 1. I'm just going to hit the clear button and hit enter, and that'll clear out all that data. And now I'm going to input this new data, which is heart rates. Okay. So I have those 5 data entries in there. Now I'm going to go back to Stat, and I'm going to go to Calculate and select one variable statistics. And I'm using list 1 again, so I'm good there. So I'm going to scroll down to Calculate, hit Enter, and it's going to give me X bar. Okay, that is the mean. So I'm going to put this in here with the mean, or X bar is equal to 175 BPM. That's just short for beats per minute. Okay, and let's go back to the calculator and scroll down and see what the median is. The median is 140. Okay, beats per minute. So there's a big difference here between the mean and the median. It's not so close like it was in the last example. Okay, see how close these were? They were only off by 4 cents. Now they're off, these are off by 35 beats per minute. The reason the mean is a lot higher than the median is because of this outlier. This outlier has pulled the mean upward. Because when you find the mean, you're adding all those values together. And so if one of those values is really big, it's going to make the mean look a lot larger than it actually should be. Okay. So does there appear to be any outliers? We answered that. Now, if so, let's remove this value and then recalculate the mean and the median and see what the difference is. Okay. So I'm going to go back to my calculator. I'm going to go back to my list. And I'm going to scroll down to 325, and I'm just going to delete it. And then we'll go back to Stats, go back to Calculate, and do this all over again. Now let's see. Oh, look. So now the mean is 137.5 without the outlier. Okay. And then the median, let's see what it is. $137.5. So without that outlier, the mean and the median are actually the same. Okay. So then the question is, which measure of central tendency would be better? The mean or the median? Well, I would say the median, because it gives us a better idea of what the true center is. Okay, it really excludes the outlier. Okay, because we know in this case the outlier is in fact an error and shouldn't even be in there. So whenever there are outliers, guys, the median gives us a better picture of where the center of that data distribution is. Okay. So the median would be better. All right. Let's see. I think what we'll do, we'll go over this last little part right here, and then I'll stop this first video. Okay, so let's think about this hypothetical. So suppose I took a survey of this class, and I asked you, what is your yearly income? And we calculated the mean, the median, and mode. Okay, and so you know, there might be some data values, maybe 15,000 a year, maybe 25,000 a year, maybe 50,000 a year, okay? But I wouldn't imagine we would get any 100,000s or 200,000s or anything like that, okay? Okay, so the mean, median, and mode might be relatively close together, okay? But what if Elon Musk walks into the room? And I know at the time of this recording, he's kind of a controversial figure right now. But nonetheless, I put him in here because he is, at this time, supposed the richest man in the world. You know, the way that, financially that is. He may be poor in other metrics of what it means to be rich, but nonetheless, the metric that they use to measure financial wealth, he is supposedly the richest. So what if he walked into the room and then we recalculated the mean, median, and mode? He would be an outlier, or his income, yearly income, would be an outlier. And because of that, guys, his yearly income is in the billions. It would pull the mean up so far that it would make the rest of us look like all millionaires. The average would probably be in the millions, maybe the low millions, but nonetheless. Now, would you say that would be a good measure of the average? I would say no, because obviously we're not all millionaires, are we? Okay, but that one outlier would skew the mean so much that the mean is no longer even accurate. But the median would probably stay almost the same. Okay, it would vary very little. And so in this case, again, the median would be the better measure of central tendency. Okay, so that's just a hypothetical, but it gives you a real sense of how outliers can really affect the mean. Because our yearly incomes would be in the thousands, and his would not even be in the millions. It would be in the billions. So anyway, all right, and then it is important to know what average, because sometimes people will use this term loosely. They'll use the average to refer to both, maybe sometimes the mean and sometimes the median. So it's important to know, if you're looking at a study and they use that word average, which is actually being used. Is it the mean or the median? Typically the mode is not used all that much. Okay. But anyway. All right, so I think we're going to stop for here. We're going to pick up in part 2 looking at the different shapes that some of these data distributions can have. So for example, just real quick, the shape of this distribution, most of the data is over here on the left, and there's very little over here on the right. And then this distribution is, most of the data is kind of on the right, and then we have kind of more, it's starting to kind of fall off on the left. And we'll talk about the different shapes that when you make a histogram with a set of data, the different shapes that those histograms can have. Okay? So this is interesting. But anyway, this will be in part 2. So I'll see you there.